Okay, so the correlation value of 0.87 indicates a strong correlation, strong positive correlation. Okay. Now, if you want to go through the route of hypothesis testing, when you are dealing with correlation, okay, what you do is this. When you are dealing with correlation, your null hypothesis, wait, now coming, just a minute. Let me see if I can show you something here. Just give me a few minutes. Dealing with correlation or regression. And you want to go through the route of hypothesis testing, which, like in this case, is not, you don't have to, it's not necessary, right? Well, you just need the correlation, and with that, you can make your decision. But if you choose to do that, then your null hypothesis will state that there is no relationship. Okay? Your null will state that there's no relationship, while your alternative will state that there's a relationship. You understand? That's if you choose to go through that route. Okay, but like I said, it's not absolutely necessary in this case. The correlation figure alone is enough for you to make your decision. Okay, so any question? Is everything clear? So, like you can see, as an analyst,
Sorry.
yeah,
This
yeah,
piercing, the 0.8705, you said is a high correlation.
yes.
So sorry, I know you've told us before. So, what's the level for when it's lower? How do we know when it's low? How do we know when it's high? Like, what's the set target?
Actually, technically, for correlation directly, you want to do something high, very high, okay? To
Okay.
be on the safe side, you know.
Okay, it's most likely to be high.
Usually when we are doing regression, for example, okay, usually we do R squared, and then we say if R squared is up to like 70.
Yes.
Okay, yeah, that's what we consider as high. Now,
Yeah.
if you are to do that, look at this, our correlation now. See, I believe it should be close to somewhere around that. So you could use two. Can you see that? You see that if you square this now,
Yes, sir.
you are getting 75. Okay.
Yeah.
Yeah. So I would say, as a rule of thumb, at least from 80 something, maybe 85. So, once it crosses 80, at least you are within safe
Okay.
range. Yes.
Okay.
Okay. That tells you,
Okay.
because the strength, when it's very high, you are it's more. That's why I said we don't need the hypothesis test. We don't need to be looking at p-value. This is what we are looking at. Okay, so
Yeah.
if you square it and you have more than 70, you are good to go. 70 and above, you are good to go.
Okay. Okay. Thank you, sir.
Yeah. Okay, so we can see that I decided to just, from time to time, I like us to do something practical like this. So we really understand the nature of analytics. You can see that in analytics, you are faced with lots of decisions. And if you take the right decision at each point, you don't have any problem. But making a wrong decision, can really, really create a problem. For example, um, first of all, you must understand the nature of the question. Okay, so you study the question carefully, study the problem very carefully, and then ask yourself, one, what type of data am I dealing with?
Yeah.
Then two, what am I testing for? What am I looking for? Like in this case, we are looking for relationship.
Relationship.
Okay. What am I looking for? Am I trying to compare to see if there's difference in mean? Am I trying to see if there's difference in proportion? Okay. Am I trying to see if the value of one variable depends on the other variable? If that were the case, this would have been something like regression. Okay. Let's say, for example, what we had there was advert expenses versus sales,
Is
because we know that sales depends on adverts. Okay. So that's you are dealing with a dependent variable, a dependent relationship. Then you'll be talking about regression. But here we are talking about relationship, but we are not asking, we are not trying to know if one depends on the other one, if one of them is influencing the other one. Nothing of such is stated in the question. It's just simply relationship. Are you following?
yes,
Now,
sir.
in regression analysis, you are dealing with relationship quite all right, but the relationship in regression analysis is always a what they call causality relationship. In other words, it's a cause and effect relationship. Okay, when it is proven that there's a direct connection, that a change in one variable is what is producing a change in the other variable. Okay, something like that. Then we'll be dealing with regression. But when it's just a simple relationship without any indication of cause and effect, then that will be just correlation. And that's the kind of problem we are faced with here. Okay. So that's it. I hope we all got the same value. Hope we all got it. Is there anybody that has any issue with this?
Got the same value, sir.
Okay, thank you. All right, so that will be it for today.